We are continuing our exponential function graphing and writing functions. Okay, so this one, we starting at 1, so we have y equals 1 times something to the x power. Okay, we need to find out what that something is. And before we were looking at what we can multiply by, well, what do we need to multiply 1 by to get 1/5? Well, multiplying by 1/5 will do. Okay, if I multiply 1/5 times 1/5, multiplying straight across, 1 times 1 is 1, 5 times 5 is 25. Okay, so that works. 5 times 1/5, putting the 5 over 1, 1 times 5 is 5, 5 times 1 is 5, 5 divided by 5 is 1. Okay, so that's still working, cool, times 1/5. Okay, 1/5 is what goes there, and we have our function, yay! Okay, at 0, we are at 4, y equals 4, something to the x power, okay. Well, 1 times 4 is 4. Is 4 times 4 7? Nope. So it's not that. Wait a second. Doesn't this add? Add 3. 7 plus 3 is 10. 10 plus 3 is 13. That's not exponential. That's linear. Okay, so y equals 3x plus 4. Nice review. Okay. So, graph the function that identifies its domain and range. Well, we're going to do the exact same thing we did yesterday. -2, -1, 0, 1, and 2. 8 ninths to the -2, so 8 to the -2, 9 to the -2. Use the reciprocal, 9 squared over 8 squared. 9 squared is 81, 8 squared is 64. I have no idea what that is. Well, it is on 81 divided by 64. 1.26-ish. Okay, 8 ninths to the -1, 8 to the -1, 9 to the -1, 9 to the first, 8 to the first, 9 eighths. That's 1 1/8, which is 1.125. Okay, anything to the 0 power is 1. 8 ninths to the first, 8 to the 1, 9 to the 1, it's 8 ninths. Is 0.8 repeating. Why didn't I know that? Jeez. Okay. 8 ninths to the second, 8 squared, 9 squared, 64, 81. Equals 0.79. Okay. That's weird. Okay, so -2 is 1.26. -1 is 1.125. 1.8, 0.79. Okay, so what we notice is instead of going up as we get our x values bigger, we are now going down. This would be an exponential decay function. Okay, because of that different direction change. And it is because this is smaller than 1. Okay, so all of the ones where this number is smaller than 1 will be a decay function. Oh, domain and range. All reals and range y is greater than 0 still. Okay, next one, xy. -2, -1, 0, 1, and 2. -1/8 to the -2. -1 to the -2, 8 to the -2, -8 to the -2, oh, +2 because I flipped it. What am I doing? 1 to the second. 8 squared is 64, 1 squared is 1, so -64. Don't think I'm going to be able to fit that on this paper. 1/8 to the -1st power, -1 to the -1, 8 to the -1, -8 to the 1st over 1 to the 1st, -8. Okay, -1/8 to the 0. Well, this whole thing will be 1, so it'll be -1. -1/8 to the 1st. Oh, -1/8 to the 1st to the 1st. -1/8 to the 2nd. -1 to the 2nd, 8 to the 2nd, -1/64. Okay, so -64, there's no way I'm fitting that on this paper. -8, 0 is -1, 1 is 1/8, and 1/64, that's so close to 0. But again, we'll never get there. Okay, again, we're decaying. We're getting closer and closer to 0 as we get to those bigger x values. Domain. All reals. Whoa, too many L's. Range. Y is less than 0 because it's below the x-axis. Okay. Ooh, a little bit more complex / fun ones. X, Y, -2, -1, 0, 1, and 2. 2 times 1/5 to the -2. 2. 1 to the -2 over 5 to the -2. Flip it. 2 times 5 squared over 1 squared. 2 times 25 over 1. 2 times 25 is 50. 2 times 1/5 to the -1. 2, 1 to the -1, 5 to the -1. 2, 5 over 1. 2 times 5 is 10. 2 times this to the 0, which is 1. 2 times 1 is 2. 2 times 1/5 to the 1st is 2 times 1/5 over 1, which is 2/5. 2 times 1/5 squared. 2 times 1 squared, which is 1, 5 squared. 2 times 1 over 25 over 1, 2 25ths. Okay, so 50, not happening. 10, well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 0 is 2. 1 is 2/5. 2 is 2 25ths. Wait, it stays above. Okay. X, Y. -2, -1, 0, 1, and 2. Oh, domain and range. All reals. Oops. Range. y is greater than 0. -2 times 2/3 to the -2, -2, 2 to the -2 over 3 to the -2, distributing that power to 3 squared using the reciprocal to change those powers positive. 2 9/4 over 1, 18/4 is 4.5. -2, 2/3 to the -1, -2, 2 to the -1, 3 to the -1, 2, 3 over 2 over 1, 6 over 2 is 3. Okay, -2, 2/3 to the 0, so -2 times 1, which is -2. -2, 2/3 to the first, -2 over 1 times 2/3, -4/3. -2 times 2/3 to the squared, -2 times 2 squared over 3 squared, -2 times 4/9 over 1, -8/9. Okay. What happened? Why did those become positive? Don't know how those became positive. They didn't become positive. Okay. These should have had switched graphs. Anyway. -4. Oops. 1, 2, 3, 4.5. Okay, -3. -2. Oh, it's by 2's. I hate when I do stuff wrong. Okay, let's try that again. 2, 4.5. -3. -2. -4/3, which is 1 1/3. And almost 1. Okay, that's a really steady curve. Domain, all reals, range, y is less than 0. X, Y, 2, -1, 0, 1, and 2. 2 times 0.25 to the -2. 2. Oh, I hate decimals. That's 1/4. So it'll be 4 squared, which is 16, which is 32. Let's double check if I'm right. 0.25. I'm right. I win. Okay. 2 times 0.25 to the -1, so that's 1/4. So it'll be 4 over 1. 4 times 2 is 8. 2 times 0.0225 to 0, which is 1. 2 times 1 is 2. 2 times 1/4 to the first, so 2 divided by 4 is 1/2. 2 times 0.25 squared. 1/4 times 1/4 is 1/16. 2 times 1/16 is 1/8 or 2/16. Okay, negative 2, not going to happen. Negative 1 is up at 8. 0 is up at 2. 1 is up at a half. And 1/8. Decaying really rapidly for that one. Okay, tell whether the graph represents an exponential function, exponential growth, or exponential decay. Well, growth, because it's getting bigger as it goes. Then write a rule for the function. Okay, so at 0, we are up at 4. So we know it has to have a 4 in front. Y equals 4 times something to the x, right? Well, we don't know what that something is, but we have this other point. So we're going to put those in. 1 equals 4 times something. And the x is negative 2. Okay, divide by 4, divide by 4. 1/4 equals something to the negative 2 power. Well, we would deal with that negative power by putting it over 1. So 1/4 equals 1 over something squared. Well, what squared is 4? Question mark is 2. So let's see if that works. 2 to the 0 power is 0. 1 times 4 is 4. Okay, so y equals 4 times 2 to the x power. Okay, this one is decay because it's going down. At 0, we are at 2, so we have 2 times something to the x power. Now we need to find out what that is. We're going to put in 6 and 17. So 17 equals 2 times question mark to the negative 6th power. Divide by 2, divide by 2. 8.5 equals something to the negative 6th power. So, over 1, 8.5 equals 1 something to the 6th. It's going to have to be smaller than 1. Well, we can multiply by question mark to the 6th on both sides. 8.5 times backwards question mark to the 6th equals 1. Divide by 8.5. Divide by 8.5. Question mark to the 6th equals 1 over 8.5. Question mark to the 6th equals 1.1176. And then we're going to take the 6th root of both sides. 6th root, 0.1176. Or, okay, take my answer, to the 1 divided by 6th power. So 0.7. Question mark is 0.7. So y equals 2.7 to the x power. That was particularly yucky. Computer value. Our decay is amount principal 1 minus our rate to the time. Okay. So the principal is $3,000. 1 minus 20% is 0.2 to the t. Okay, so 3,000 times 0.8 to the t. And then plugging in these will get us our values.